Hello, everyone. Welcome to 125th videos of this channel. So this channel has grown from very few videos now to more than 120 plus episodes of mathematical videos. So if you haven't subscribed this channel yet, it's now time to consider click that bell button to subscribe the channel so you can access to all the 120 plus videos. So, okay, today we're going to talk about question 8 of the VCE 2020 methods exam. Now, this question, it's a lot of small questions, leads to a very important concept of we call the function and its inverse function never intersect, do not intersect. How do we decide that? So this will be last question we'll talk about it. But before I start, I'm going to go through some of small questions based on the question listed on the 2020 VCE exam question paper. So first question. So we got a fx. It's a log x times by log x. The log is natural log, so we have a graph. So we need to find out what is the first question. We have a Q, which is the turning point. We don't know what A is, so we need to decide the coordinates of the point Q. So that's pretty easy. So Q is a minimum point. So that means derivative fx must be equal to 0. So we differentiate fx equal to 0. We solve for x, which is e to the power -1. So it's 1 over e. So therefore, the coordinate of the point Q, the x coordinate is, so A is e to the power -1. So FA, so we substitute e to the power -1 into their function, which is e to the power -1 log e to the power -1. So therefore will be negative. We'll bring into -1 to the front, become log e. So we know log e is 1. So the answer will be -1 divided by e. So therefore Q will be e 1 over e, and the y is -1 over e. So that's it. That's first question. So question B, we use the derivative of x squared times by log x to decide the integration of the antiderivative x times by log x. So let's do that. So we know the derivative, if I integrated both ends, so we got the x squared times by log x is twice of integration of that plus integration of x. So I'm going to move this because I need to have the antiderivative of that. So I'll put antiderivative that expression times by 2 equal to x squared minus log x minus integration of antiderivative of x. So we divide by 2 both ends, so the answer will be pretty simple. So we have a new techniques to find the integration without using the integration by parts. We're using derivative. So that's very good methods to solve antiderivative with x times by log x. All right, next question C, to find the, so we have the area of a region bounded by fx and x to the power x, which is here. So basically we want to find that little area. Oh, actually, sorry, it should be on the right hand side if I draw this. So that's the area we want to find out how. So that's the area. We need to know what is the area of this particular shape. So we say fx is x times by log x. So we need to decide what is the b first, so that we can have an interval. So when we solve for the b, we by just using the y-intercept, lead to fx equal to 0. So we got x equal to 1 because the other 0 is, we don't need it. So we use x equal to 1. So we solve from a. What is a? We already know is 1 over e. We decided at a previous question, but we need to put a negative here. Why negative? Because it's below the x-axis. So we put a negative sign. So integrate it, because we done the question before, we know this integrated antiderivative of x log x is this. So we're plugging those values in, so we'll get the final answer is this. So just plugging the simplify to that. So don't forget to check your answers thoroughly, see if you got the correct answers. Next one. The next one is called GX. GX is called the vertical translation. We put a K, translation factor is K. So we want to find the value of K, for which y equal to 2x is a tangent to the graph. So it means when you do tangent, we need using derivative to find a gradient. So we differentiate gx. So when the derivative of gx equal to 2, because y equal to 2x, that's the gradient, which is we given is 2. So therefore we solve for x, which is e. So now because of the e, this x is the tangent, the point on the tangent is on the graph. So we substitute into the g. So because of the y equal to 2x, so we know so we found the y become x is e, so 2e. So this is the intersection point between tangent and the gx. So this point is also on the gx, so we substitute into the gx to find the k is e. So we decide as e. So down to that, so this means with gx, in this case, is fx, which is x log x plus 2. So that's the plus e, sorry. So that means I shifted the gx is upwards, so go translate upwards by e value. Next question is the one I'm going to talk about a little bit more details because that one is involved with the concept of G and the G inverse of G do not intersect. So what is the what I mean by those two functions cannot intersect? Now, some students may decide to find the G inverse first, then we say cannot if they cannot intersect means they can not have so we solve for solutions like a gx equal to G inverse to see if we have a solution or not. So that approach is a very long process, take very long, and you might have a limited successful because it's very hard to find the inverse of G from this equation. So this approach is probably won't be successful. So now I'm going to introduce a new concept. So when you talk about the Gx and the G inverse cannot accept, it means because y equal to the x is called symmetric x. So that means the graph, if they're not interested, because they're symmetric, so they have to be away from each other, so they cannot touch. So we need to prove two things. First, we need to find out the gradient of Gx has to be same as y equal to x, gradient of y to x, which is 1. Secondly, we need to prove the graph has to be concave up. So we know concave up means the second derivative must be always positive. So that's why concave up. Otherwise, if you say I have a same gradient, but they can do that way. So they still can be touched. So those two functions can join. So we have to avoid that. So two things I want to prove. The first is find that the gradient equal to 1 of Gx. So that's easy. So we put derivative function here first, m equal to 1, we solve that, so the x equal to 1. So if I'm using touch, first I'm going to say this is my Gx, which is a touch the gradient of this is y to x. So y to x is the tangent, so I'm going to solve for y, so G1 is 1, because it's y equal to x is x equal to 1, y also equal to 1. So we solve for the k, we found that k is 1. So in order to, then we're going to test to see if a g double derivative function is always positive. So we double derivative of g become 1 over x. Now, because of x is always positive, can you see the condition we given in the question? So this the domain is positive. So therefore, the x is positive, so the double derivative always positive from that domain. So therefore, Gx is always concave up. So we prove those two. So this is the situation we are given. So now we want to say this cannot touch because we don't want to touch the, so this is a G inverse. So that's to intersect. So in order to then not intercept, I want to lift up. So I'll say that when k equal to greater than 1, so therefore this will be vertically translate above the y to x. So they cannot touch the y to x. Since the inverse also symmetrical to the gx along y to x, so g and the g inverse do not intersect. So that's the situation we are talking about. All right, so that's approved. So k must be greater than 1. so that gx and the g inverse will not, so do not intersect. Doesn't have to be solving g inverse of g. All right, so this is a long video, but this is a very important concept. So how do you prove, how do you say a function will not intersect with its inverse? All right, thank you for watching. If you enjoyed the video, please give us the thumbs up. I'll see you next time. Bye-bye.